guys, so today I just wanted to do a few more examples of solving systems of linear equations. Monday we went over this, but all of your activities were you just putting things on the computer. So today I do want you to actually get out your graph paper and graph some of these to figure it out. So that's why I'd ask on Monday if you needed graph paper. I have put in the mail everybody who said they needed it. So if you don't get it today, you should get it by tomorrow so that you can do this on graph paper. All right, so again, first thing we want to do is put each one of these in slope-intercept form. Slope-intercept form is y equals mx plus b. Which means we want to get y by itself, and we want the x term before the term that doesn't have an x. So we have 4x plus 2y equals 10. So to get y by itself, first thing I'm going to do is move the 4x. So I subtract 4x. Or I can think about if I'm putting it on the other side that switches its sign. We did that a little bit when we were rearranging quadratic equations. These are not like terms, so you cannot take 4x from 10. So you put this first and then put the 10, and since it's positive, you put plus 10. Then you're going to divide everything by 2 to get rid of that 2. So that leaves me with y. Negative 4 divided by 2 is negative 2x, and 10 divided by 2 is 5. So for that line, my y-intercept is 5. So on the y-axis, I start at 5. And then my slope is this number, and I want to make it a fraction. So I put it over 1. The 2 is negative, so that means we go down, and what's on the bottom tells us to go to the right. So we go down 2 and over 1. And you'll want to do this quite a ways on your graph. And if you want to go points this way, you go up 2 and left 1, do the opposite. Because you don't want to just put 2 points and then draw the line, because if we don't draw it neatly or with a ruler, then we may not see the exact line, the exact point where they intersect. So you want to draw out quite a few points there. Then the other one is already in slope-intercept form. If there's not a number over here, that's understood to be 0. So that's the same as like plus 0. So that means we start at 0, 0, the origin. And then the slope is negative 2 over 1. So from there I go down 2 and over 1. I can go up 2 and left 1. Put some points this way. So what we should see are parallel lines. If we're not sure because we're not drawing them neatly if they're parallel, if they have the same slope and different y-intercepts, that's the key. Same slope, different y-intercept, then they are parallel. The point of this is to find the solution. So this isn't the answer. This is how you get your answer. Like this graph is your work for the answer. And so your answer is where they intersect. Well, parallel lines are never going to intersect. So my answer is no solution. Now this is one on this next one that we haven't seen that I want to talk about. So we have x plus y equals 10. So I subtract x, and I get y equals negative x plus 10. So I start up here at 10. And then my slope, that's understood to be a 1, so that would be negative 1 over 1, so I go down 1 and right 1. There's a few points there. Then on my other line, to get y by itself, I need to get rid of this 3, so I divide everything by 3. So negative 3 divided by 3 is negative 1. And 30 divided by 3 is 10. So what you should see is that now we just got the same exact equation. So I'd start at 10 and go down 1 over 1. So basically I just got the same line. So if I'm looking for where they intersect everywhere. We call these coinciding lines. So these are parallel when they have the same slope but a different y-intercept. These are called coinciding when they have the same exact slope and y-intercept. They're the exact same line. So that means they intersect everywhere. So that means there are infinitely many solutions, because every single point on those lines are solutions, because they intersect everywhere at every single point. So there's an infinite number of solutions. All right, let's go over one more. So these are already in slope-intercept form for us. So this one, the y-intercept is 3. 1, 2, 3. The slope is 4 over 1. So I go up 4, because that's positive, and right 1. I can go left or down 4 and left 1 to get some points this way. And then for this line, the y-intercept is -6. And the slope is 1, because that's understood to be a 1. So that's up 1 over 1. Alright, so for the points I have plotted, I can't really tell. So that means I got to extend this on over here. So instead of going up 1, right 1, I'm going to go down 1, left 1. And then I can see that I had to extend that on in the opposite direction so that I could see this point where they intersect, which is 1, 2, 3. So -3. -9. So that would be my solution there. So today you're going to practice graphing on graph paper, and you will submit pictures of that. And we also have a new program we're going to be looking at possibly today, so that'll be on your assignment. But on your graph paper, you're going to either have parallel lines where it will be no solution, coinciding lines where it will be infinitely many solutions, or 2 just lines that intersect and that point where they intersect. All of these should come out where they intersect at whole numbers or integers. There shouldn't be anything where it's in between. So next week we'll be looking at, okay, what if I graph 2 lines and they intersect like right here where I can't tell what it is? And then we'll want to do that algebraically. So that's what we'll learn next week. All right, have a good day and message me any questions.